Welcome to the second tutorial of Beegraphy. In this tutorial, we will be looking at data type and structure. This is related to the data that flows through the wires that we connect between components, the input and output. And the data types would include point or numbers or line, curve, plane, so many things. We're going to look at that. We are also going to look at data structures, how this data flows through the wires when it becomes a bit complicated, when there are several number of points going through the same wire. So how does it manage it? Secondly, we will look at different components such as rotate, move, sequence. Very simple. And finally, we are going to look at a very basic structure, how to create a twisting tower. So just studying the first two aspects, the data type and component, will be really boring. So we are going to create a twisting tower from scratch and learn about data type and structures and the components as we try to create a twisting tower. So that will be more interesting and it will be a more hands-on approach where I would like you to be involved in it. So follow along as we create a twisting tower. Let me first explain to you how we are going to achieve it. So we need a twisting tower. So there will be a base or rectangle that we will create. And then we are going to replicate it by moving in the Z axis. So let me create another rectangle here. So this is the original rectangle, and then when we have the new rectangles coming up, which will be in black in this sketch, I've moved it up by, let's say, 3 units, and then I'm going to repeat this to create a series of rectangles, multiple floors for the building. Okay, so it's pretty simple. First we create a rectangle and then we move it up, but we move it up multiple times. Let's say n number of times, and this will be the gap, 3 units. Numerically, what is happening is the first one is 3 units up, the second one is 6 units up, and the third one is 9 units up, and so on. So it is an arithmetic progression. It's just a table of 3 that's happening, like 3, 6, 9. So what you're going to do is we are going to simply take our first rectangle and keep replicating it by with a distance of 3 units, then 6 units, then 9, then 12, and so on. That's what we are going to do. And then finally, we are going to rotate each of these things. So let's say the first one. So let's say the first rectangle that we have replicated is rotated by 2 degrees. Then this one is rotated by 4 degrees. This one is rotated by 2, 4, 6 degrees, and so on. Okay, so there are two set of numbers that we have, 3, 6, 9, 12, and then 2, 4, 6, 8 for the rotation. And we need to somehow associate these numbers with the respective rectangle. So 3 is associated with the distance it has moved up, and it is associated with the first replicated rectangle. And also 2 degrees of rotation is associated with the first um, replicated rectangle, and then 6 units will be for this one, 4 degrees will be for the same thing. So this is how we are going to look at this problem and tell the computer what to do basically. So you open up your browser and then type in beegraphy.com. You got this page, you log in. I'm already logged in. Then go to editor, and let us create a new model, and we'll name it 02 tutorial twisting tower. Okay, so this has opened up, and we'll turn on the solver and begin. So firstly, we want to have, let's go to perspective. Firstly, we want to have a rectangle in our plane. Let me increase its size. And let's just double click on the canvas and type in rectangle. There are several types of rectangles we've got. So I would like you to play with all these 4 different types of rectangles and see what is the difference between all of them. But for the sake of this tutorial, I'm going to stick with rectangle by center. So we already have this rectangle. When we click on it, it highlights as yellow, and it has some default values: width of 20 units, length of 10 units. You can change it to make it a square and see it's instantaneous. Let's do 15 by 20. Okay. And origin, by default, it is at the origin of this Cartesian coordinate plane, which is 0, 0, 0. See this one. If you want to see what happens if you change it, you can do that. Basically just moves our rectangle. Okay, now what we're going to do is we are going to look at how moving works. Now move is very different in this case in computational designing and virtual scripting. When we move something in the traditional softwares, the original geometry itself moves from point A to point B. But in this case, let's see what happens when we do that. Now the geometry that we want to move is this curve. Curve is the rectangle. Okay, so it has moved by default to 10. So it has moved 10 units in the x direction, 10 units in the y direction, and then 10 units in the z direction. It has moved diagonally through the 3D space. We don't want that. We just want it to move vertically up. So there is no x element to it, there is no y, just z. And we want to move it by, let's say, 4 meters, 4 units. Okay, but you can see that the original still remains. So what is happening is, when we create a script with all these nodes, components, all of them exist simultaneously. It is not like when you create a line and then you move the line, the original line itself is moving. That's not how it works here. So there is an original rectangle and then you are moving it. So the moved rectangle and the original rectangle both will remain, and this is a set of commands that we are giving. So if we change the original rectangle, its moved part or the moved rectangle will also change with it. I'll show you. So it's not that these two are independent entities. This is the original rectangle. If I change its width, you see the moved rectangle's width is also changing real time. And if I even move the rectangle itself, the associated moved rectangle is also moving with it. And that's the beauty of it. Like from now on, whatever we do to this rectangle, creating this entire rotating structure or anything, if we change anything here, the entire tower is going to change, entire model is going to change, because that is the original geometry which is being transformed step by step. So yeah, just take a moment to digest this method. So all right, so we've moved and created like one floor. Now we want to do this multiple times. So I'm going to explain like what we want to do, and then I'm going to share with you another component which will help us to do this easily. If you remember in the sketch, this is what we wanted. The first rectangle is 4 units up, z is equal to 4. The second floor is 8 units up, and so on. I'm just doing Control C, Control V, copy paste, and this will be 12 units up. So manually we can do this, but if it is like 100 floors, then it's very cumbersome to actually copy paste everything and then keep on increasing this till it reaches the desired number, and keep on doing that. And then if let's say the client says that we want 3.5 units floor height and not 4, then you're gonna change everything. Even if you put a slider and put it into all of these things, it's a very heavy script, unnecessarily heavy script. So we are going to use a command called sequence. A list sequence. Now what it does is it will create a list of numbers that we want, like 3, 6, 9, 12 and so on. And this is the input. Where do you want to start this list of numbers from? So it's starting from 0, then it is asking how many numbers do you want. So in our case it will be the number of floors, which is 5, and then what is the gap between each number. So that is a step, and here it is 1. In our case we need it to be 4, and let's say we want 10 number of floors. And here when you want to see the output, you can simply click here and click on this arrow to get the output, and play with these numbers and see how the outputs change. Like right now it is 5, so there are only 5 number of numbers. Also remember that the counting will always start from 0 in computer engineering, computer science, scripting and all of that. It does not start from 1, it starts from 0. So 4 means there are 5 number of items. Now when we are talking about such words, list, items, these are actually technical terms that we use for this data structures. List is a set of items. Items can be anything. It can be points, it can be numbers. It is basically data. All right, so in this case, the data is in numbers, the data type is numbers, and the list is consisting of 5 items. If we want to increase the number of items, we are going to increase this count. Okay, now there are 10 items. This is each item. 12 is an item, 16 is an item. Also, you can see that there are different colors. So blue corresponds to numbers, and then these green correspond to coordinates. You see x, y, z, vector also x, y, z. And there is pink, which is geometry, and then and you see this is data type, which is a curve. And if we click here, type number, so this is data type, this is a number. Then here also data type, geometry. So this is really nice in Beegraphy that we've got color coding for different data types, so it's much easier for us to understand. So, and the data type should match, the input and the output data type should match. Sometimes it is okay because curve is a geometry, so it can go into geometry, but you see this is a number data type and this cannot go into this coordinate data type, vector data type. So that's why it is not even accepting it. Like I'm trying to connect it, but it's not connecting. If you are working on a Dynamo or Grasshopper, it will connect and then it will show an error in this node that the data type is not matching. So how to resolve this? Basically, it is asking for a vector. A vector is not simply a number. It is XYZ coordinate. It's slightly complicated. So to convert, or let's say to create a vector with all of these Z values, up Z values, I'm going to type in vector Z. Just type in Z and you'll see this vector Z pop up. And now you see the input is a number data type number, and the output is vector data type, and this will go into here, and you can see that this has happened. Also, the vector is also being shown by this arrow, blue colored arrow. And if you remember what vector is, there are two types of quantities: scalar quantities, vector quantities. Scalar quantities are things like distance or speed, where there is just a magnitude. For example, 5 meter. How far is it? It is 5 meters. How fast is the car moving? 5 kilometers per hour. Vector is a combination of magnitude and direction. So if I ask how far is it and I say 5 meters, that's a scalar quantity. But if I say 5 meters in east direction, then now this has become a vector quantity. Similarly, the car, if it is moving 5 kilometers per hour, then that is a scalar quantity. But if I say that it is moving 5 kilometers per hour in north direction, then it is a vector quantity. So here also it is not asking for just the magnitude, which is 10 units. It is also asking us which direction. And by this component, vector z, vector z, we are telling it the direction is up. And now if I connect this to here, the 10 is replaced with this list sequence. Also see the thickness of these lines have changed. So if there is only a single item that is going through, then the line is like this, and if it is more than one, like in this case there are 10 items that are going through this line, this wire, then it is thicker. And in 3D model space we can see that we have a tower which is 10 number of floors, and there is 4 units of distance between each of them, and we can control it from here. 3 units, 2 units, and the number of floors you can increase or decrease as per your liking. And also if you play with the start part, you can see there's the initiation is different. Okay, so right now I'm gonna just coincide with the base rectangle. Alright, so the first step is done. We have created a series of rectangles. Now we want to rotate it. Each of these rectangles need to be associated with the required degree of rotation, like 2 degree, 4 degree, and so on. So let's look at the rotate command. This one, just simply rotate. And this is in radians, like 1.571. It is asking for center. It is asking for the geometry, which will be the rectangles. And then there is the vector. Vector means the axis of rotation. So by default it is 0, 0, 1. So it is what we want. It is perfectly correct. The center is also correct. We want it to rotate around the origin because our rectangle is also at the origin coincidentally. If the rectangle is moved, then it won't work. We will figure that out later. All right. So if we put this geometry in, it rotates by pi by 2, which is 90 degrees, which is 1.57 in radians. And if we type in radians to degrees, sorry, degrees to radians, because it is accepting radians, degrees to radians, then we'll be able to convert and put it into the angle correctly. Because right now if you put in like 90, it won't be 90 degrees, it is 90 radians. So this component will convert 90 degrees into radians, and let me see what is showing, 1.57. Now it is 90 degrees, and you can see it is rotating slowly. Okay, that's 60 degrees and so on. I'm gonna take a range input so that we can change the numbers easily. And if we want it to be super quick, then we can do live calculation. So now we can see the rotation happening. But currently the entire tower is being rotated, right? We don't want that. We want only the first tower to be rotated by 2 degrees, the second, sorry, the first level, first floor to move by 2 degrees, and the second floor to move by 4 degrees, and so on. And the ground floor will move by 0 degrees. So we can see the same pattern like before. So we are going to create a list sequence again. I'm going to remove this. I'm just going to copy paste. Let's just throw it in. Now this is the same as the number, the floors sequence. But let us put in a number slider so that it's easier. We call it range input in Beegraphy. And you can control the twist. And we are going to hide everything else so that we can see only the final outcome. Perfect. But if you remember, I said that if we change the location of the base rectangle, then things will go awkward, like it is happening here. You see, these rectangles are not being rotated around their centroid, their center. They are being rotated around the origin. That's why it is looking like this. Now if you don't want that, we want it to rotate around their own rectangles, then there is a command called centroid. Or you could use the area command. No, actually. And then use this and just a second. Center of mass, center of bounding box. So I think this one is the correct one. And then you use this at the center to get the outcome that we want. Centroid gets the centroid of all these rectangles. As you can see, these blobs that have popped up. When you click on the blob, this is highlighted. And each of these rectangles, when they are being rotated, they are considering their centroid as the center of rotation, and the axis is 0, 0, 1. If you want to play and just see what happens if you do something like this, you can do that and see what happens. Basically, the axis of rotation is changing and you get different forms. Alright, so now if you move the rectangle anywhere, it doesn't matter, it's always gonna be the same. Alright, what else is left? We've got, so everything is in our control now. Actually, let's put in range inputs for even this, that you can quickly control it. There is one thing that has left out, the number of floors. So when I put this as number of floors, and if this does not coincide with the number of degrees of rotation that we have created, then this happens. You see, it is rotating, and then it just gets static. If that's the design you are wanting, then that's cool. But if you don't want that, and you always want it to rotate no matter how many floors you create, then you have to increase the count of this degrees that we are creating, the series of degrees that we are creating. And so we are going to connect this with the count of the degrees, and now no matter what you do, it will always rotate. No matter how many floors you create, it will always rotate. Perfect. If you want to create, let's say 3.5, then go to your range input and then reduce the step to 0.1 or 0.5 depending on the accuracy you want. Then it becomes 3.5. So every floor height is 3.5 now. Okay. So I hope this cleared your concepts for data types. Data structure is a massive topic, but this was a nice glimpse of how things are being correlated, like the data of the list of rectangles is being related to this list of items, these numbers that are being created. These are all the rotation values in radians. So this is associated with the ground floor, this is associated with the first floor, and so on, and they merge into this rotate, and super smartly it is arranged in such a sequential manner that all of these are not jumbling up. They are all perfectly aligned to give us this structure. Alright, so I think this was good to introduce a few of these new components and introduce the concept of data structures, data types, and we also got this interesting tower which you can play around with and even change these width and see what happens. Don't be scared to do random things, like I just put in, like I change this vector to see what happens and get weird forms, interesting forms. yeah, just play around with things and try to understand through that. See you in the next one. Thank you.